Hello everyone. Our lesson today is Unit 3 in Algebra Probability. First, we want to remember the sets. If we have here set X and Y, Z, we have the elements on the set X 1, 2, 3, 5 and 6, and the elements in Y 5, 6, 8, 9, and the element on the set Z is 10. And we have the sample space which contains the three sets. Okay, first we know the intersection here, X intersection Y. It means the common element between the set X and set Y, which is in this region 5 and 6. So we have here the elements common between X and Y, X intersection Y equals 5 and 6. And the number of intersection X and Y, what the meaning of N here? It means number. Here, X intersection Y, how many elements? 2 elements. So the number of X intersection Y equals 2. Okay, what about the union? X union Y equals all element in X and all element in Y, and in sets don't repeat. So we have here 1, 2, 3, 5, 6, 8 and 9. We don't repeat 5 and 6. And also the number of X union Y, it means here how many elements in X union Y? We have 7 elements. Okay, here we have X intersection Z. We don't have common element between X intersection Z, so we have X intersection Z equals 5, and we called X and Z two mutually exclusive. If we don't have if we have two sets, the intersection between them is 5, we called them mutually exclusive. And the number of X intersection Z is 0 because we don't have any intersection between them. Here we have X minus Y. It means the element in X and not in Y. The elements in X and not in Y, which is 1, 2, 3. So the number of X minus Y equals 3. And Y minus X, or Y difference X, it means all element in Y and not in X, which is 8 and 9. And the number of Y minus X equals 2. Finally, X complement. What the meaning of X complement? All the number in the sample space except X. It means we have here 8, 9, 11 and 10. Again, 8, 9, 11 and 10. And the number of X complement is 4. Okay, what about Z complement? All elements in sample space except Z. It means here 11, 1, 2, 3, 5, 6, 8, 9. And finally Y complement. It means 1, 2, 3, 10, 11 and so on. Here if we have A subset of B, it means here A is smaller than B, subset from B. So the intersection between A and B equals A. And if we want to get the union A union B equals what? Equals B. Okay, we studied in the previous years the probability, and the probability of any event equal the number of event over the whole number of event. Okay, and we know the probability is greater than or equal 0 and less than or equal 1. If the probability equals 0, we call it impossible event, and if equal 1, we called it sure event or certain event, or between 0 and 1, it's possible event. Okay, here we have some examples. Probability, it means 6 over 9, maybe 4 over 9, 1 over 10, 2 over 9. Here it will be fraction, but less than, greater than or equal 0 and less than or equal 1. Okay, here we have some operations. If we have two sets X and Y, we want to get the probability of X union Y. As we said, X union Y, it means what? It means all elements in X and all elements in Y and don't repeat. So we called here probability of X plus probability of Y don't repeat. It means minus the intersection between them, this region. Okay, so the probability of any two sets, like probability of A union B, it means probability of A plus probability of B minus a probability of intersection between them. Okay, here if we have two sets mutually exclusive, as we said, we don't have any intersection between them, so the probability of the intersection equals 0. So the rule here, it will be probability of X plus probability of Y minus 0, so we can't write it. We have an example. Probability of X equals 0.6, probability of Y 0.3, and we want to get the probability of X union Y. If probability of X intersection Y 0.5, okay, direct in the rule, here we have probability of X union Y equals what? Probability of X plus probability of Y minus intersection, substitution. Probability of X 0.6, probability of Y 0.3, and here we have the intersection 0.5. Using your calculator, the result will be 0.4. And if X and Y mutually exclusive, so the intersection between X and Y here equals 0. So here we get X plus Y only 0.6 plus 0.3 equals 0.9. Okay, and we studied the complement. As we said, the complement all element except the set itself. Here, if we have probability of X dash equals 1 minus probability of X. Again, probability of X dash equals 1 minus probability of X, and probability of A dash equal 1 minus probability of A, and so on. And we have here rule probability of X plus probability of X dash equals 1 or equals 100%. 1 or 100%. Okay? We have an example. Probability of A dash, find probability of A dash if probability of A is 0.7. So direct in the rule, as we said, probability of A dash equals what? 1 minus probability of A. So 1 minus 0.7, it will be 0.3. And the difference, here we have the probability of X here equals what? Equals probability of X minus Y, which is here, this region, plus the probability of the intersection, which is this region. So here X, it will be two parts, probability of X minus Y plus probability of the intersection. So here remove X minus Y in this side and remove probability of X in this side. So we have probability of X minus Y equals probability of X minus probability of the intersection. Okay, and if we have the two sets mutually exclusive like this, we don't have any intersection between them. The intersection between them equals 0, probability of the intersection. So direct in the rule, probability of X minus Y equals probability of X. And also here probability of Y minus X equal probability of Y. We have an example. Probability of A equals 0.6. Find probability of A minus B. And we have the intersection 0.2. So direct in the rule, here we have probability of A minus B first minus second. So probability of A minus probability of the intersection. Okay, so 0.6 minus 0.2, which is 0.4. And second, if we have the two sets mutually exclusive, so here, as we said, the probability of the first, probability of A minus B equal probability of A, which is 0.6. We have another rules. If A, B, and C are three events, and S is the sample space, as we said, As we said before, probability of A equal the number of A over the number of sample space, which is the total. Okay, over number 2, the probability of non-occurrence of the event A. If we have in the example non-occurrence of the event A, we called it probability of A complement A dash, which is 1 minus probability of A. And the probability of occurrence of the event A only, it means A minus B. A only, it means A minus B. And as we said before, A minus B equals what? Equals probability of A minus intersection. Here, the probability of occurring the two event A and B together. A and B together, it means the intersection. A and B together, it means the intersection. Here, the intersection we have here, probability of A plus probability of B minus union. And if we want to get the union, we said probability of A plus B minus the intersection. Okay, vice versa. Here, the probability of A and B both, or at least we have the union. As we said, the union يبقى A plus B minus the intersection. Okay? If we said here, the two sets are mutually exclusive, as we said, what the meaning of mutually exclusive? The probability of the intersection between them equals 0. Equals 0. So here A minus B equals what? Equals probability of A minus 0, which is probability of A. Probability of B minus A, probability of B minus intersection, it will be probability of B. Probability of A union B equals probability of A plus B minus the intersection. Here intersection 0, so it will be A plus B only. And here, if we have A and B mutually exclusive, here A and here B. If we have A subset from B, here we have A, here is the small subset from B. So the intersection will be the small, which is probability of A, and the union will be the greatest probability of B. And if we have here probability of B minus A, it means here 0. Probability of phi, we don't have element B minus A, so it will be 0. Okay? Here, probability of the sample space, as we said, equals 1, which is certain or sure event. Here, probability of possible event will be greater than 0 or less than 1. Probability of A union A dash, as we said, 1. So we said here probability of A plus probability of A complement equals 1. Probability of A intersection A complement equals 0. Of course, we don't have any intersection between A and its complement. Probability of A complement union B complement, it will be all complement, but change the sign. Here union, it will be intersection. So here if we have probability of A complement intersection B complement, it will be probability of all complement, but it changes the sign. Here we have intersection, it will be union. Okay, we have some examples. Number 1, using this opposite diagram, Venn diagram, to find here n of s. What's the meaning of n of s? Number of sample space. Okay, count how many elements. Here we have 1 2 3 4 5 6 7 8 9. So we have here 9 elements. The probability of A intersection B, it means the number of intersection over the number of sample space. Here, how many number of intersection? 2, which is 1 2. Here 1 2, it will be 2 over number of sample space equals 9. Okay, another one, probability of C complement. Here we have A B C. C complement, it means all element in the sample space except the C. So here we have C here. So here the rest of the element 1 2 3 4 5 6. So here the elements of C complement equals 6 over the number of sample space 9. Don't forget to put it in the simplest form, which is 2 over 3. Okay, another examples. Here number 1, the probability of A equals probability of A complement. So here we have A and A complement equal 1, equals 100%. Here they have equals, so here we have half to B probability of A and the other half to probability of A complement. So the probability of A equals half, and also the probability of A complement also equals half. If A and B are two mutually exclusive, so A intersection B equals what? Equals phi. In experiment, if tossing a dice, what the meaning of dice? Dice, it will like dice here we have the sample space of it from 1 to 6. 1, 2, 3, 4, 5 and 6. Okay, the probability of getting number greater than 6, here we have any number greater than 6? Of course not. So we have here 0 over total 6, which is 0. Here don't set phi, here we called about the probability number. Okay, number 4, A and B are two mutually exclusive. Mutually exclusive, it means what? The intersection is 0. Probability of the intersection equals 0. Okay, here probability of A 5 over 12, probability of the union 7 over 12. We want to get probability of B. Okay, direct in the rule. Here probability of A union B equals probability of A plus probability of B minus the intersection. As we said here, mutually exclusive, so the intersection will be 0. Direct in the rule, union here 7 over 12. Probability of A 5 over 12 plus probability of B. It's an equation. Remove probability of B in the other side. It will be here 7 over 12 minus 5 over 12, which is 2 over 12. So the probability of B equals 2 over 12. Another example, if A is an event of the sample space of random experiment, and if probability of A is 3 over 8, find the probability of A complement. As we said, the sum of them is 1. We want to get complement, so 1 minus 3 over 8. Using your calculator, 5 over 8. The probability of impossible event, as we said, is 0. Certain event or sure event equals 1. Regular coin, here sample space of the coin, we have head and tail. The probability of getting head equals how many percent? As we said, head and tail, two halves. So how many percent? 50%. If the probability of occurring an event A is 65%, then the probability of non-occurring, here occurring event and non-occurring event, the sum of them is 100%. So the rest of 100 from 65% will be 35%. Okay, here probability of A union A complement, of course 1. The probability of A intersection A complement, of course 0, not phi. We called about probability number. Okay, finally, if the probability of A equals 4 probability of A complement, then probability of A equals what? Okay, in the rule here, as we said, probability of A plus probability of A complement equals 1. Remove probability of A and we have a new name equals 4 probability of A dash. So remove probability of A and write 4 probability of A dash, and write probability of A dash as it is equals 1. Here 4 probability of A dash plus probability of A dash. A dash here like x. It's an equation. 4x plus x equals what? Equals 5x. So we called 5 probability of A dash equals 1. We want to get probability of A dash equals what? 1 over 5. Remove 5 in the other by divided. But in the example, we want to get probability of A. So probability, we have here probability of A dash. So the probability of A equals 1 minus 1 over 5 equals 4 over 5. Why? Because we said before, probability of A plus probability of A dash equals 1. Okay? Number 12, a basket contains 5 red marbles, 7 white, and the remainder will be green. If the probability of red equals 1 over 4, find the probability of green. Okay, here direct in the rule, we will solve it here. Number 12, the probability of red equals 1 over 4. What's the meaning of probability of red? The number of red over the total or the number of sample space equals 1 over 4. Number of red equals what here in the example 5. يبقى 5 over total equals 1 over 4. Cross multiplication, so the total will be 5 times 4 divided 1 equals 20. So the total of the marbles is 20. We have 5 red, 7 white, and the remainder will be green. So the number of green equals what? 20 minus 7 plus 5, which is 8 marbles. Okay? Here number 13. If A and B are two events, okay, probability of A 0.5, probability of B 0.6, the intersection 0.4. A find the probability of occurrence at least one of the two events. At least it means what? Of course it means union. So we want to get the probability of A union B. A union B equals what? Probability of A plus probability of B minus intersection. Direct in the rule. Probability of A equals what? 0.5 plus 0.6 minus 0.4, it will be 0.7. Okay, which is number A. Number B. Here occurrence B and non-occurrence A, so it will be B minus A. Probability of B minus A, as we said, probability of first minus the intersection. Probability of B 0.6 minus 0.4, it will be 0.2. The last one. Non-occurrence of A, it means A complement. The probability of A complement equals what? 1 minus probability of A. So 1 minus 0.5, also it will be 0.5. Okay, thank you.